Hello, pre-calculus students. Today we're going to talk about section 5.4, which is applying trig functions. So you will need something to write with, you'll need your notes, and you will definitely need a scientific calculator today. Okay, remember to pause and try all of these problems. It's a lot of practice today, but try them first, read them first before I go over them, just to see, kind of what you already know. So let's start with the first one. So you're given a right triangle and then asked if J is 50 degrees. So that we're going to use capital letter J, capital letters for angles, and then the side across, we're going to use the lowercase letter. Okay, so if this is angle J, then this is going to be side little j. If this is angle R, the side across is little r. If this is angle G, then the side across is lowercase g. Okay. So we know angle J is 50 degrees. We know side J is 12, and we want to find R. So this is what we're looking for. So everything is going to relate back to this angle here, angle J. So the side I'm looking for is across from the right angle. That's my hypotenuse. And the other side that I know is across from J. So that's my side opposite. And so then I'm going to think of my three trig ratios, sine, cosine, and tangent. Which one relates opposite and hypotenuse? So the one that relates opposite and hypotenuse is sine. We know the sine of an angle is the leg opposite over the hypotenuse. So we know the sine, in this case, we're talking about angle J. Okay, so the sine of 50 degrees equals the side opposite, which is 12, over the hypotenuse, which is side R. And that's what we're going to solve for. So this sine of 50 degrees, that's something that we can put in the calculator, right? So, there was back in the day, the mathematicians, they figured out all those ratios for each of those angles. What was the ratio, the length to the opposite or to the hypotenuse for each angle, and then that was a particular value. So sine of 50, if we put that into our calculator, is going to give us a value. So we want to solve for R. And the way I would do this is I would think of it as multiplying both sides by R, or you could almost think of it as cross multiplying. Okay, so then I'm left with R times the sine of 50 equals 12. Okay, and then to get the R by itself, I'm going to divide by the sine of 50 degrees. Okay, so notice I'm not calculating what this decimal is right now. I'm going to do that kind of all in one step over here. Okay, so then this cancels out. So R equals whatever 12 divided by the sine of 50 is. And I would just put that into my calculator all in one step. So if you're using Desmos, the scientific calculator, it would look like this. Again, if you just Google Desmos scientific calculator, this will come up. And so I want 12 divided by, and I could use this guy here, the A over B, and I want the sine of 50. Now I need to make sure my calculator's in degrees, and you can see right here that the degrees is what's showing. Okay, so it tells me it's 15.66, so about 15.7. In general, it's going to be fine to just round to the nearest tenth for your final answer. So R is 15.7. Okay, so go ahead and read example 2 and try example 2. Think about how you might set that up. So out of focus. Okay, so chair lift at a ski resort rises at an angle of 20.75 degrees and attains a vertical height of 1,200 feet. That's right here. So you can kind of see this triangle that we're focusing in on. And the question is, how far does the chairlift travel up the side of the mountain? Okay, so here's my chairlift right here, and I want to know how long is this path. So for part A, it said I'm trying to find length D. Okay, so I know this is my hypotenuse of my right triangle right here. Okay, I know the side across from the angle, that's opposite. So I think, okay, well, what trig ratio relates opposite and hypotenuse? It's sine again. So the sine of my angle, which is 20.75 degrees, is 1,200 divided by D. And then I'm going to solve that equation. So I can multiply both sides by D. And so then I have D times the sine of 20.75 equals 1200. And then to get the D by itself, I'm going to divide by that 20.75. And I would just put this into my calculator because this all cancels out. So when I put 1200 divided by the sine of 20.75 degrees into my calculator, I end up with 3,387 or it ends up just being 0.0 feet. When you round to the nearest tenth, it bumps you up to the 87. Okay, so then part B, a film crew in a helicopter records an overhead view of a skier's downhill run from where she gets off the chairlift at the top to where she gets on the chairlift for her next run. If the helicopter follows a level flight path, what is the length of that path? So I want to know this length. Well, you can see I could kind of make that, those two triangles are congruent, right? So it's really like I'm trying to find this length in my triangle. So I'm going to give that a variable. I'm going to just call it x. So I found out that this was 3,087 feet. So I've got a couple of options here. I could use the Pythagorean theorem, right? I could do 1,200 squared plus x squared equals 3,087 squared. I could solve it that way. I could say I'm going to keep the 20.75 degrees. This is opposite. Oh, what am I looking for now? That's adjacent. What relates opposite and adjacent? I could use the tangent. So there are lots of different choices. Do whatever you feel most comfortable with. Just so you know, the answers might be slightly different just because of rounding issues, right? Because here we rounded to get that answer. So if you do use the Pythagorean theorem, it could be a teeny tiny bit different than if I used the tangent. That's okay. We know that when we look at your work, we know that that is a possibility. So if I multiply both sides by x, I'm just going with this to practice using the trig ratios, but definitely like Pythagorean theorem, totally fine. Okay, so I have 3,167.3 feet. Okay, let's take a look at the next one. Okay, so the next one, go ahead and read it and think about how you might set that up. Okay, so a regular hexagon, so I gave you a regular hexagon, is inscribed in a circle with a diameter of 26.6 centimeters. So imagine that this was in a circle, like in these vertices of the, this is really bad. The vertices of your hexagon would touch right there. They told you the diameter is 26.6 centimeters. So from here to here is 26.6 centimeters. Find the apothem of the hexagon, apothem. The measure of the line segment from the center of the polygon to the midpoint of one of its sides. So from the center to the midpoint of one of its sides. So for example, here, right? There's a bunch of them though, right? Here is an apothem, here's an apothem here. And again, with the diameter, you could have connected any vertices you could connect them all just to keep it less messy. I'm not going to. So I want to figure out this length here. This is my apothem that I'm trying to figure out the length of. Now this is perpendicular and we're talking about triangles. So somehow I want to get a triangle in there. And so what I'm going to do is I am going to sketch that in. Okay, here's another diameter. Really, I should have drawn it up against this one, that diameter I had already drawn, but here's another diameter. That's also 26.6. So then I know how far it is from here to here, right? Because that's a radius. So then that is 13.3 centimeters. Okay, so I know one side of my triangle. I know a hypotenuse. I want to know this to use a trig ratio. I need to know an angle, right? So is there a way that I could figure out the length, the measure of any of these angles in here, right? So think about all the way around this circle here is 360 degrees. In this triangle, right, or in this triangle here, right there, how many of those triangles? 1, 2, 3, 4, 5, 6. If I split the 360 into 6, that's 60 degrees. This is 60 degrees. That means this has to be 30 degrees. And so I could focus in on this triangle right here. So I could, and I'll redraw it here, maybe zoomed in a little bit. So this is 13.3. That's 30 degrees. This is my right triangle. This is what I'm looking for. It's supposed to be an A. Okay, so now it might be easier for you to see what you're trying to figure out. So in regard to this angle, I know this is my hypotenuse because it's across from my right angle. This is my side adjacent. What uses adjacent and hypotenuse? That's cosine. So the cosine of 30 equals adjacent over hypotenuse. Okay, to solve this, I'm going to multiply both sides by 13.3. So then cosine of 30 times 13.3, just put that in your calculator, is about 11.5 centimeters. And that was kind of tricky. You have to remember that stuff about geometry. Don't freak out too much about it. Okay, one other thing that we are going to use a lot, just kind of throughout, is this idea of angle of elevation and angle of depression. And here's an example right here. The angle of elevation is the angle between the horizontal and the line of sight. So this right here is our line of sight looking upward. Okay, so this right here is my line of sight. So it's the angle between the horizontal and the line of sight looking up. Okay, so my angle of elevation is this one. Okay, my angle of depression is the angle between the horizontal and the line of sight as you look down. Okay, so the angle between the horizontal and the line of sight as you look down. Okay, so my angle of depression is this right here. Okay, so I want you to read and try to start example 4. It's really going to be helpful to draw a picture to get started on example 4. Okay, so an observer in the top of a lighthouse determines that the angles of depression to two sailboats directly in line with the lighthouse are 3.5 degrees and 5.75 degrees. If the observer is 125 feet above sea level, find the distance between the boats. Now, I am not even going to attempt to draw a lighthouse. It will be a disaster. So, I mean, if you're imagining like, okay, here's like my beach. Like imagine, there's my lighthouse, okay? And I know my lighthouse is top is 125 feet. So here's my lighthouse. Imagine it's some beautiful lighthouse on the Great Lakes, right? That's 125 feet. Okay. And then it says there are two boats. Now, this is not going to be drawn to scale. It's not going to happen. I can't draw my angles, so fine. But I've got two boats, right? So let's say here's boat 1, and let's say here's boat 2. And they're telling me the angles of depression. So that's between the horizontal. So I'm going to draw on this horizontal. And then I've got an angle of depression like here, right? And I've got an angle of depression here. And they say the angles of depression are 3.5 degrees and 5.75 degrees. Okay, so the angles of depression are between the horizontal and line of sight. So my line of sight to boat 2 is this guy here, right? So to boat 2, here's my angle of depression. That's smaller, so I'm going to call that the 3.5 degree angle of depression. And then to boat 1, here's my angle of depression right here. To boat 1, that's the bigger of the two angles. Obviously, those are not drawn to scale, right? I'd have to have a huge piece of paper. It's just not happening, guys. Okay, so this angle here is 5.75 degrees. Okay, and what I want to do is I want to figure out how far the boats are, like how far is boat 1 from the lighthouse, how far is boat 2 from the lighthouse, and then I could figure the difference between those, and then that would give me my distance between the two boats. Okay, so it kind of looks like a mess right now, but if we kind of maybe draw them separately, it might help you to kind of see the triangles better. So what you should sort of be seeing is, oh, here's a triangle right here, right? And here's my angle. And could I figure out this distance? And then here I have another triangle, and I have this angle here. Could I figure out this distance? It might be easier if we were to draw it as two separate triangles. And I'm realizing I drew this way too big, and now we can't. I'm not going to be able to fit every single thing. But here I'm going to draw two different lighthouses. And I'm going to do it on a separate sheet of paper so that we can actually see them a little bit more clearly. Okay, so here's my 125 feet again. And let's say that this was my boat 1 right here. And boat 1 was the one with the line of sight that was 5.75 degrees. Right? Now, one of the things, these are parallel. One of the things that we know about parallel lines is that we have alternate interior angles. So if this is 5.75, then this is also 5.75. And what I want to do is I want to figure out what this length here is. That's how far boat 1 is from the lighthouse. Okay, so if I have this angle right here, and I know this side across, and I want to know this one next to it, this is opposite, and this is adjacent. So I could do something like the tangent, right? Opposite and adjacent is tangent of 5.75 equals 125 over x. And I could multiply both sides by x. And I could divide by the tangent 5.75. Okay, and then you go ahead and you put that in your calculator and you get 1,241.4. Okay, so that means on my drawing from here to here is 1,241.4 feet. Okay, now what I'm going to do is kind of the same thing, but with the other angle of depression, right? So this is still 125, but remember this angle of depression was 3.5 degrees. Okay, I want to know this length now, which let's say we call y. If this is 3.5, so is this. Okay, so I can go through the same process and say now tangent of 3.5 degrees equals 125 over y, and then multiply by y, and then divide. So 125 divided by tangent of 3.5, which is y and not an x. What do I have? 2043.7. Okay, so then that means that this distance from here to here is, what did I say? 2043.7 feet. Okay, but the question was how far are the boats from each other? So to figure out the distance between the boats, we would subtract. So 2043.7 minus 1,241.4. So about 802.3 feet. Okay. And there it is in the homework, right, where you're going to have to draw something and have these angles of elevation and depression. Just kind of take some practice. Okay, pre-calc students, take care, everybody.